So, hello everyone. Our first speaker is Michael Staib. He will talk about how to build applications with GraphQL and Blazor. He is the author of Hot Chocolate Project, which is a platform for building GraphQL. This is the second time we have him on the .NET. Please welcome him. Michael, you're on.
Thanks for the introduction. Hello, everyone. I'm Michael Staib. I'm a Microsoft MVP, and as already mentioned, of the Hot Chocolate GraphQL library for .NET. Today, I'm doing a holiday version of my talk. I'm sitting here in Italy. That's one of the good things about the lockdown. You can do your talks from everywhere. But let's get started. Today, I want to talk to you about building real-time applications with GraphQL and Blazor. And with Blazor, Microsoft, for the first time in years, gives us .NET developers a viable solution for building rich SPA applications that run natively in the browser. But we are not stopping there today. We are taking Blazor to the next level by removing the friction of data fetching for the front-end developer. I know a lot of .NET developers still don't know what GraphQL is, or maybe have the wrong idea about what it could be. But fear not, I will bring you up to speed what GraphQL is, and then we head into the talk. So GraphQL was originally introduced by Facebook back in 2012, first for their internal platform. And they started work on GraphQL in order to make the data fetching between their mobile applications and their backend more efficient. But they didn't just make the data fetching more efficient, they changed the way we interact with our application layer. But let us explore it a bit more in depth. So if we look at this little example here, which is a very simple GraphQL query, we are basically asking the GraphQL server to give us the currently signed in user, and from this currently signed in user, just the name. And if we would send that to our GraphQL server, we would get a response that closely aligns our. We could almost say that the GraphQL server just filled up our request graph with some data. It is actually not like that, but it's a good mental picture to start thinking about how GraphQL works. As we develop our UI further and introduce new components, we might want to change our request. And with GraphQL, that is very simple because GraphQL is driven by the consumer of the API. So the consumer, for instance, can just ask for another property on this user object. For instance, for the profile picture. And from the profile picture, we want the width, the height, and the UL of that profile picture. And again, if we send that to our GraphQL server, we basically get a response that closely aligns to our request structure. But if we look at that, we can also see that it's now not only about flat data structures, it's also about data trees. So with this, we could reflect more on that and think, yeah, actually, that is a good thing. With this, we can access related objects of our user or of the object we are requesting. And that allows us to push the data aggregation back to the server. For instance, we could ask for the currently signed in user. And maybe on our platform, we want to build up an online list that shows the online status of the friends of this user. So we could also ask the server for not only the currently signed in user, but also for all the friends of that user and for the online status of that friends. And again, the server would just fulfill that request. And the server actually might do that much better than if we had the data aggregation on the client side or in our UI framework, because the server might get this data in one go from one of the downstream services. But if we look at that simple request here, we can see that there is also some repetition in there, which is not good. Like name and last seen, we use it 2 times, 1 time for the user and 1 time for its friends. But in GraphQL, we have a construct which is called a fragment. And a fragment basically is a primitive for composition. We can create in our requests or in our queries fragment hierarchies as we create class hierarchies in our backend, or as we create component hierarchies in our front-end UI components. So with GraphQL, I can fetch everything that I need from one endpoint because I'm controlling the requests. Then there don't have to be multiple endpoints that represent maybe different resources. And I can fetch everything that I need at one specific point in time through one request. And that really gets rid of the problem on the client side or on the front end side, which is called the over or underfetching problem. Overfetching always happens when the predefined request is too general and offers too much data for my use case. And I still have to consume that extra data that I actually don't need and throw immediately away. And underfetching is the opposite problem, where the request on the server side actually does not offer enough data, which means I have to issue cascading requests and basically create those data waterfalls where each request is dependent on its previous request. But GraphQL is not only about efficiency. GraphQL introduces a strong type system that lets you consume the data without fearing that maybe a string becomes an int or something like that. When the GraphQL server tells you this field is a string and this field is a non-nullable string, then this field will never become an int and never become null because the GraphQL request engine will ensure the data consistency there. And this all makes GraphQL super predictable to use. But let's head into Blazor now and explore what Blazor is. So with Blazor, I said Microsoft introduced a new way for us to build SPA applications. And it is really the first time that Microsoft lets us do that without any plugin technology involved. Because when Microsoft started work on this, they took the mono runtime and rebuilt it so it runs on WebAssembly. And that actually means we are running full .NET Core in the browser. And if we reflect on that, running full .NET Core in the browser lets us really use all our components that we have written over the years or that we use in the backend and just use it in the browser, like dependency injection or JSON.NET or the HTTP client factory and other components. What it also means is that we can use less JavaScript and almost write everything in pure .NET code. And I myself am quite rubbish at JavaScript, but I'm confident using .NET. All of this is running at near native performance, and it's running on top of WebAssembly. So WebAssembly is an open standard that every modern browser implements, apart from Internet Explorer, which I don't consider a modern browser anymore. And all of Blazor is open source, like all of ASP.NET Core. You can head to Microsoft's repository, look at the code, and file issues, or even do a contribution of new components. But let us have a look at how Blazor actually works. So in order to write Blazor components or Blazor applications, we are using a combination of C# and Razor syntax. And this really compiles into standard .NET assemblies. When the browser downloads the Blazor application into the browser, it also downloads the mono runtime. And the mono runtime really allows us to run standard .NET assemblies in the WebAssembly VM. That's basically a sandbox in the browser. WebAssembly applications are not actually able to manipulate the DOM directly. That is why Blazor is building up something called a shadow DOM, or an internal component representation, And every time we are doing some state changes in our components, add a text or do some dynamics things or catching some events, we're actually subscribing to the internal component tree and modifying that. And then there's a little piece, little JavaScript piece that takes all the changes that we do to our internal representation and patches those to the actual DOM. It does it very efficiently in batches. And it also works the other way around. Every time a user changes the DOM by typing a text into a text box or clicking on a button, these changes are batched onto the internal component representation and lead to event triggers within our Blazor components. Okay, before we head into our demos, let us shortly look at the state of Blazor. Where is Blazor today? So Blazor for Server was actually released back with .NET Core 3.0. It is sufficiently stable and runs at massive scale. The only limitation that you have with the Blazor for Server is basically that you could run out of memory. So the more users you have, the more memory you need in your backend. But this May, Microsoft introduced Blazor for WebAssembly. So Blazor moved essentially from the server into the browser. And with that, the scaling issues that you could have on a server with multiple users are basically gone. You just have to scale your data fetching endpoints, so either your REST APIs or your GraphQL APIs. But Microsoft is moving from the browser back to the desktop. So with .NET 5, they are introducing Blazor for progressive web apps and Electron as previews once .NET 5 releases. But they are not stopping there. They have a lot of experiments, even funny experiments like Blutter, which renders Flutter components just as an experiment to show off how versatile Blazor really is. But they are having more serious experiments with Blazor mobile binding. So basically, you could say we started as a server, moved into the browser, moved onto the desktop, and now are going into the edge devices like mobile phones and tablets. Okay, enough of all the introductory talk. Let's get into some code. And when I thought about what could we code in a talk about real-time data fetching with GraphQL and Blazor, I immediately thought of Slack, because Slack underneath uses GraphQL to do all the data interaction with the server. And it's really predestined to show all the aspects of GraphQL, because you can do simple data fetches to get the user list. You can do GraphQL mutations, basically changing the server state by typing messages and sending them to the server. And you also have real-time data coming in. Whenever a user writes you a message, this message just flies into your chat in real time. Okay, let's go into some demo code. And for that, let me go back to the desktop. And let's open the first demo. This is a simple Blazor application. And before I walk you through, let me just .NET run that. And I show you how it looks like at the moment. I just built up a simple shell that we can use, so we don't have to code all the HTML here. Yeah, so here's my basically the shell of my application that we are building here. And at the moment, we have a side that shows the participants or where the participants should be. They are at the moment just placeholders here. And in the middle, we will have all the message bubbles or the chat area where we can communicate. And at the end of our demo, you all are invited to send in messages. We have a little demo site where you can go on and send me messages right into my debug session. But let's get first our code right, and then we go into some fancy live testing. Okay, so if we open up Blazor project like this one, we immediately see there is something. Let me just kill the server. We can immediately see there is a thing called program CS. A program CS, we all know. We use it in console applications, in ASP.NET Core application. It's very familiar for us. And like with ASP.NET Core application, we have a host builder. But instead of our default host builder, we are using a WebAssembly host builder here. And instead of defining middlewares like use MVC or use GraphQL, we have components in here. And in this instance, we have a component called app. And if we go to that component app, we just have inside of this component another component called main. And this main component is in our components folder. In Blazor, we have a concept like in React, where you have smart and dumb components, or stateful and stateless components. Main is our stateful component, where we aggregate all the state. And how that works is actually that the smart components push down the data to their component tree. And the dumb components or the stateless components interact with the other components by throwing events. So if we go into our people list, which is a stateless component, we can see some HTML here. We can see that we have some components here, a person placeholder, actually 3. That was when we started the application. You saw them in the left-hand side. And if we go in the person placeholder, we just see HTML. And then we have the person item, and that will actually represent in a minute our user in that list. Okay, so in order to fetch data with GraphQL here, we first have to initialize our project to do that. I already set up the project to use Strawberry Shake. So we have a local tool here called Strawberry Shake Tools. I only need it because I'm using VS Code. If you're using Visual Studio, you would not need that. And then we also added to the project already the Strawberry Shake package. So our project actually had the servers called Hot Chocolate. The client is called Strawberry Shake. So a cold drink for the front end and a hot drink for the server. Okay, so in order to initialize our project, we need our console here. I just clear that out. And then we do a .NET GraphQL init. And we have to add the server URL. I have that here, so just to paste it in so I don't forget it. And I also want to give my client that we are going to create here a name. So I call it chat. Let's hit the enter button, and it actually downloaded a file that is called a GraphQL schema that tells my local solution all about the types that the server has. Everything now compiles against this schema. And in order to now formulate GraphQL requests, we need another GraphQL file. We could call it anything we want. I call it queries.graphql, but you could call it foo.graphql. The compiler will find the appropriate GraphQL files that you write. Okay, now we want to write some GraphQL queries. I head over to a tool, a GraphQL IDE done by our project. It's called Banana Cakebop. And I already set it up with our server. And I can already see in our Schema Explorer on the left-hand side the fields that my server offers. The first thing we want to do is to fetch the persons I can chat with on the left-hand side. So all the users I can interact with, I want to fetch with a GraphQL query. And there is a good field that I see here. It's called people. It exposes all the people, all the person objects that I can fetch from that server. And with the Server Explorer, I can explore already my types on the server before I did the first request to my server. You can see that people returns a person connection, which is a paging type in GraphQL. And I actually have a lot of persons on there that I can then use. Okay, let's write a GraphQL query. A GraphQL query starts with query. And this, what I'm writing here, is called an operation. This operation I call get people. And now I'm basically telling my GraphQL server what I want for data. So I'm taking the people, and from the people, the nodes, as I saw in the Schema Explorer. And then I can choose the fields that I want from that person. So maybe I want the ID, the name, the last seen timestamp. So basically when the point in time when this person was last online. And maybe I want the email. Let it be this that we need here. Let's execute our query. Oh, I can see that I get the data I asked for, but I also can see that it has a strange order, and the Hot Chocolate server has filtering enabled on the backend. So we can ask the server to give us the stuff in a different order. So we ask it to be ordered by name in ascending order, send the request back to our server, and we can see now the name state start with an A. Okay, let's grab this query, paste it in our queries.graphql, and let's compile our Blazor solution here. And what happens now is that we can see there is now generated code, and I can see there's a person interface. And if we look at that, we actually have 4 properties here, the exact properties that we define in our GraphQL query. So what Strawberry Shake does here is to compile the right types for your queries that you have defined there. And if we look at the client interface, we can see that the operation became basically a method. So I have now a get people method on my chat client that I can invoke. Okay, let's prepare our components and build up our client here. So we first go to our person item. And let's introduce some code here. And in order to pass data down into our component, we need something called a parameter. So what we are going to do is to create a property called user, which is a person, and that is annotated with a parameter attribute. And this allows us to now push data into that component. So now that I have a property here, I can add an add here and basically make this code here. Let's actually say a Blazor syntax. And now we are using the last seen property from the user and the name property in our HTML to display basically our user props. Okay, so our person item is done. Let's go to the list. And in the list, we also need some data in. We need the person list in here. So let's add some code, as we did in our first component. And now we want the people to be passed in. And this property is, again, a parameter. We can pass data in here. And it presents the list of people that we want in our list. Also, we want a loading indicator here to display some different elements, our placeholders, when this component is loading. Again, we use a property so the outer component can indicate when data is being fetched. So we call that isLoading. Okay, now it's easy. We just add a simple if isLoading. Then we actually want to display the placeholders. And else, if there are items, we want to iterate over the people that we have and add for each person a person item that represents our user. Okay. Done with that, we can go back to our main component, our stateful component that does actually the data fetching. Let's add some code here. And we also add a lifetime method here. This on initialized async is an override of the actual base component methods, lifetime or life from Blazor. And we actually now can intercept when the component is initializing. At that point, we want to do something, fetch some data. And in order to bind data to our component, our people list, we need to have some properties here. Is loading, no, not a property, let's do a public bool is loading a field that is initially false. So no, it's initially true. So when we initialize a component, it's actually loading. And then we have another one we call people, person connection, and that is our people. Okay, and we are going to bind that to our component here. So these parameters become basically attributes on our XML or HTML tag or Blazor tag, however you want to call it. And we now can bind to our field down here. Let's also add is loading. Okay, awesome. Now everything is bound. When we would start this up, our component would show the placeholders because it thinks that we are loading. So now we want to use the GraphQL client to fetch some data. And that we are going to do by injecting with our dependency injection. Like I said, we can use dependency injection. And we have a directive here. This is called at inject. And we can inject from our dependency injection the chat client here. Okay, let's grab that chat client and fetch some data. So we do a var result. And we now, as I showed you before, have now here a nice method, get people. We await that. And then on this result, we have a helper method that is called ensure no errors on this result. If there are errors, we explode. I wouldn't do that in a production app, but for the demo, it's okay. Okay, next thing, we are grabbing the data and assigning it to our people property up here. So we say result.data. We know data is not null at this point because there was no error, and the server guarantees us that there is data when there is no error. And then we grab the people and set is loading to false. Now we are not loading anymore. And then we also tell Blazor that the state of our component has changed. So we are basically done with our components, but we have to do some setup code here because we injected the client, but we never declared it on our dependency injection. So we say builder.services.add chat client. And now we need to declare how we transport the data because GraphQL is actually transport agnostic. So we are using, in this case, the HTTP client factory. So we say add HTTP client, and we give it a name called chat client. And then we define how our client should be set up. So we say it should use a base address, which is a URI. And we have our server URL here. So let me paste that in. Oh, damn it. And last but not least, we need a token. I prepared a snippet already for my token, so we just can paste it here. Token. Okay. And then we assign our token here in the default headers, default request headers.authorization. And we say it's a bearer token and it's token. So, but it's a very simple setup. We just use standard components, the HTTP client factory that comes with ASP.NET Core. Actually, as I said in the beginning, we reuse all the components that we also can use in the backend. And then we did this add chat client, and all the dependency injection code, which is quite a lot, was already generated for us. Okay, so let's run this client, our UI, .NET Run, and hope it works. Okay, it's compiling. Still compiling. Okay, it's coming up, I see. Let's try if it's already up. Yeah, it's loading. And you can see there are the participants that we fetched. So it was very simple, actually, to build out these Razor components to get some data and use GraphQL. Okay, let's go back to our slides. It is live. We did it. It didn't explode. So let's be happy. Okay. Let's have a look at the component structure. What we built so far is the people list. And that was simple. It would be simple with REST. It was simple with GraphQL, because with GraphQL, it just felt like we have a strongly typed API that is just C#. We actually, in our .NET code, never saw any magic strings, because the client is generated on build time, meaning the string you could actually throw away after building because you have a generated client. There is no magic string. And then we have our center area where we want to chat now with. This is where we want to code next. So what we need is to build out those message bubbles. So get some real-time data plugged in. And also we want to build out the footer where we have our typing area, where we send messages, mutate the server state. And yeah, let's get started with this. Let's not waste any words and go back to some code, because we developers, I think, understand code the best. Okay, second demo. This is basically the same demo that we left. I just did put some more components in. You can see we have the people components here, and then we have uncommented some chat components here. I also have the queries that appears to be empty. I'm a bit shocked, because usually I have this piece of code here, but it doesn't matter. Oh, that was just my VS Code not loading properly. So I have the queries here. Let's just drag that over here. I have an image here, so the UI, the left UI component will look a little bit refined, but don't worry about that. So again, if I execute that, I get the data. So as before, we basically have the basic setup. Okay, so before we get into the components here, let's think about the data we want to fetch. First, we need to fetch the messages for the user we want to chat with. Every time we click on one of those users, we want to have the messages of the conversations that we had with the user. Simple fetch again. Then we want to send messages to the server whenever we type something and hit enter. Last, we want to get messages coming in at real time that other users write to us. Okay, let's get to it. So we have already our get people here. So the next query we need is get messages. So we start an operation here, but this time we want to pass data in. And in GraphQL, we have a concept is called variables. It's basically the parameter. This will basically become a parameter in your method of the generated client. So I say, I want an email here. The email is a string, and the string is not nullable. So I always want an email passed in. Next, I will fetch a person with that email. So passing that email in. And from that person, I want the messages, and the server already knows who I am, who's logged in here. So it knows these are the messages that I and the user have. And again, I have a paging component here, but for the demo, we are just using the simple nodes. And so from the message, I want the ID. I want the direction. Is it incoming or outgoing? I have a recipient. Yes, we want a recipient. And from the recipient, we actually want these three properties. And we reformat that. Then we have the sender. And again, from the sender, depending on who the sender is, I need these 3 properties again. Okay, right. We remember that I don't like repetition, but we will optimize it in a second. Let me get this quicker. That's not right. Okay. Sometimes on a Mac, you have this strange. Let me get rid of that. Sender. Sorry, because sometimes on a Mac, if you click on the options key and on the spacebar, you introduce a hidden sign that the GraphQL ID has a problem with. Okay, so we have the sender in, then we want to send date, and we need the text. Okay, so we have defined our message that we want to have here, but I don't like the repetition. So we are starting to introduce a fragment now, and we call this fragment a participant. And this is a chat participant, and we apply that on a person. And then we can grab these 3 properties here and put it in our fragment. And we can use this fragment instead of the properties. Okay, we use that here as well. And actually, we can use that here as well. And then if we think about that, these actually represent a person object for our domain, for our usage domain. So we say fragment. This person is actually on person. So we define the person in our domain context. Okay. And then we, instead of using the fields up here, use person up here as well. Okay. Next thing, we introduce another fragment, and you will see why in a second, which is called message. And we introduce it on message. And we basically grab all the fields from our message here and paste it in our message fragment. Okay, instead of that, we are using now message here. Okay, nice. We have set that up nicely. Let's go on to the next. We have the query to fetch the messages. Now let's introduce the mutation to send messages in. We call this operation send message. And again, we have the email of the user who will receive that message as a variable here. And then we also have another variable called text, which is also non-nullable, which is the actual message that we sent in. So say send message. Then we have an input object here. And on this input object, we have the recipient email. Let's just pass in the email. And the text is the text that we have. Okay, our mutation is done. The upper part here actually is just the mutation. Everything that comes below a mutation is querying the changed state of the server. In this instance, I can grab the actual message that we wrote and just fetch the message. So I have the proper message object on the client side with the proper ID and stuff. And again, I just use my fragment here. Okay, last but not least, let's define a real-time subscription. So I can tell the server I want to do a subscription, which is called onReceive message. And we have some events on the server. In this case, I have an on message received. Again, the server knows who I am, so it's only about the messages for this current session. And this object is actually a message here. So I can say, again, use a message fragment. And I also can rename this field in this instance. So I call it now message. So it builds up a nicer C# API for me. Okay. Everything should work here. So let's grab it and paste it in our queries.graphql. Let's recompile our solution here. It's building. Oh, let's rebuild it. Ah, it works. Okay. So what now happened is that we generated a whole new client here. And when I go to the person interface here, I can see that the person interface now inherits or implements also the participant interface. And that's because I built up these fragment hierarchies. They translate into C# class hierarchies. Okay, I see my time is running up, so let's be quick about it and build out these components. So let me uncomment these guys here. And then we will really quickly put that together in under 3 minutes, I hope. Okay, so I uncommented the components, and I also here have an imports, general imports. All these imports are imported by each component. I have to also import the chat components. I always forget that when I do this talk. Okay, let's compile that, add to our main Razor component. So the main Razor component is actually where all the magic still happens. It's our stateful component. And we now have some more event methods here. So for instance, I have an on-click person. So when I click on a person, this event is raised. And when this event is raised, I actually want to load the messages that I have with this person. So we now can use our generated new GraphQL client here and say, get a new result from our chat client. Oh, that is not supposed to happen. Sometimes the OmniSharp doesn't like if there are files added. Yeah. So then you have to just develop a reload too. Okay, so we want to get the messages for the person on which we clicked. We want to grab from that the email. Again, we say ensure there are no errors. And last but not least, we want to store the currently clicked on user because we want to bind that to our components later. So we need a few more properties here. One we call iPerson, which has the recipient. And one we call one which is an immutable list of iMessage. And it's actually an empty immutable list. Empty. Okay. Let's grab that. Okay. When we fetch the messages, we assign that to our message list here. No. Messages. And we say immutable list, create range, grab our result, take the data, and grab the messages, and from the messages, the nodes. Okay, so this will build up our result here, our messages property, which we call differently. Okay, and then we have to assign the recipient. So the person that is passed in is our recipient in that case. And last, we say state has changed. And this will, again, update our component tree. Okay, but we have this new property, so we need to bind these. And in order to bind these, we have to add our new component that is called message list. And now we have bound to this message list the recipient down here and the messages. Actually, the recipient is actually nullable because it could be null. Okay, but let's quickly add some more here. So we have the on-click send. That's every time I click in the message list on send message, we want to mutate the server state. So we again, let me just grab this because it's actually almost the same. We grab the chat client. This time we say send message async. We pass in the message. And actually, the email comes from the recipient that we stored on our property. And this event can only be raised when the recipient is actually there. Okay. Again, we have a new message created. So we want to put that into our message list here. So we say messages dot add, and then we take from our result the return messages, the return message that we created. As I said, the mutation returns this changed state of the server, so we grab that, update our state here, and are done. Last but not least, we want to put some real-time logic in here. So let's say receive. We have a method here. I use now the snippet to be faster. I have a method begin receive messages, and we start in that task that calls on our client on receive message. And in case of subscription, the client will actually return a response stream, which is an async enumerable. So we can await for each over this async enumerable and add messages to our server. Okay, we start this when the server actually initializes. Damn it, begin, receive messages, and we are done. So we have one more thing to do, because so far we just have set up the HTTP client, but subscriptions run over WebSockets or Signal or something like this. So let's hope I have a snippet for that, because otherwise we run out of time. So we have created something like the HTTP client just for WebSockets. It comes with Strawberry Shake. It's called a WebSocket client, and it closely aligns how the HTTP client factory works. Okay, let's just start our server so we can see that everything comes together here. It's coming up. Coming. So let's go while it compiles. Yeah. And comes back up. I can select the audience. And actually, if you're interested, go on this UI and send something in. I'll just grab that. We go over here. Just one more second. Okay, so I'm now in my chat here. Go to the bottom, and now we can send in hello. And hello is coming in. So you can see it's fairly easy to create real-time applications with Blazor. And I see I've used up my time, so I leave that online. You can start sending in messages if you want, and we will see them coming in, but I'm also open for questions now.
Okay, thank you very much.
There's something coming in.
Okay, looks like it's working.
Yeah, this is real life debugging, you know.
This is really cool. So I have a question actually. Does it use JSON as a format for messages between client and server, or something else?
So your question is if JSON is a request payload, or?
Yes. Yeah.
So it depends. Actually, we are working on a gRPC integration, so GraphQL over gRPC. In this case, you don't have to use JSON. We are then using protobuf.
Oh, protobuf.
And you can actually because GraphQL is actually transport agnostic. It just prescribes that you have structured data. And in case of protobuf, we are using then these structure types from Google. So GraphQL actually could even go over sockets, over native sockets like WebSockets. In this case, we are using JSON, but it doesn't have to be JSON.
Okay, got it. Any other question, folks? I've shared the link to the demo in the chat. You can try it.
Let me just go to the Pine tool here.
And by the way, I've created a poll here. Let's do a flame war, which IDE is the best. I believe somebody will vote for VI. Michael, what do you think about it? Which IDE is the best?
My personal choice is VS Code. But I have friends that use VI and swear on it. And but I personally like VS Code. But if you are very VI focused, you could also use the VI controls in VS Code and use it like VI and still have some special nice debugging capabilities.
So, thank you, everyone. There is a coffee break. In 10 minutes, there will be second talk from Florian Verdonk from Martin F. Sharp source code. And if you have questions for Michael, you can join him in the speaker's room after the coffee break. Thank you, everyone.
Great.
Thank you, Michael.
Thanks for having me. And just let me get out.